Welcome back to the Network Plus training series. In this lesson, we're covering Objective 1.3, summarizing cloud concepts and connectivity options. Cloud computing has fundamentally changed how organizations deploy and manage IT infrastructure. For the Network Plus exam, you need to understand the core cloud service models, deployment models, and how networks connect to the cloud environments. Let's start with cloud service models. There are three primary models, and you need to know. Infrastructure as a service provides virtualized computing resources over the internet. Within infrastructure as a service, the cloud provider manages the physical infrastructure, including servers, storage, and networking, while you manage everything from the operating system up. This gives you the most control and flexibility, and I want you to think this as renting the raw computing hardware. Examples include Amazon EC2, Microsoft Azure Virtual Machines, and Google Compute Engine. Platform as a service provides a platform that allows developers to build, run, and manage applications without dealing with the underlying infrastructure. Cloud provider manages the infrastructure and the operating system, middleware, and runtime environment. You focus on deploying the code and managing the data. Examples include Azure App Services, AWS Elastic Beanstalk, and Google App Engine. Software as a service or SaaS delivers full functionality applications over the internet. The cloud provider manages everything from the infrastructure to the application itself. You simply use the software through a web browser or API. Examples of this include Microsoft 365, Google Workspace, Salesforce, and Dropbox. A helpful way to remember these models is to think about who manages what. With infrastructure as a service, you manage most. With platform as a service, the management is shared, and with SaaS or software as a service, the provider manages nearly everything. Now let's discuss the cloud deployment models, which there are four of them. A public cloud is owned and operated by a third-party cloud provider. Resources are shared amongst multiple organizations or tenants. Public clouds offer scalability, cost efficiency, and reduced management overhead. The major cloud providers are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. A private cloud is dedicated to a single organization. It can be hosted on premises in the organization's own data center or by a third-party provider. Private clouds offer greater control, security, and customization, but they come with a higher cost and management responsibility. A hybrid cloud combines public and private cloud environments, allowing data and applications to move between them. This gives organizations flexibility to keep sensitive data in the private cloud while leveraging the scalability of the public cloud for less sensitive workloads. Hybrid cloud requires careful network design to ensure secure and reliable connectivity between the environments. A community cloud is shared by several organizations with common concerns, such as regulatory compliance or security requirements. It can be managed by one or more of the participating organizations or by a third party. An important concept related to cloud is multitenancy. In a multi-tenant environment, multiple customers share the same physical infrastructure and applications, but their data is isolated from one another. This is how public cloud providers achieve cost efficiency. Each tenant's data and configuration are logically separated, even though they share underlying resources. Elasticity and scalability are also key concepts. Elasticity refers to the ability to automatically scale resources up or down based on demand. On the other hand, scalability refers to the ability to increase capacity to handle growth. Vertical scaling or scaling up means adding more resources like CPU or memory to an existing server. Horizontal scaling or scaling out means adding more servers to distribute the load. Now let's look at the cloud connectivity options. How you connect to your on-premises network to the cloud is a critical design decision. In this case, a VPN connection uses encrypted tunnels over the public internet to connect to your on-premises network to the cloud. Site-to-site VPN connects your entire network to the cloud provider's network. This is cost efficient or effective. The performance depends on the internet quality. VPN connections are commonly used for smaller deployments or as a backup connectivity option. A direct connection, sometimes called a dedicated connection, provides a private, dedicated network link between you and your on-premises environment and the cloud provider. Examples include AWS Direct Connect, Azure Express Route, and Google Cloud Interconnect. These connections bypass the public internet entirely, providing more consistent performance, higher bandwidth, and improved security. However, they're more expensive and take longer to provision. Software-defined wide area networking, or SD-WAN, is an approach to network management that uses software-based controllers to direct traffic across the WAN. SD-WAN can intelligently route traffic between on-premises locations and cloud services based on real-time network conditions. It can use multiple collections, including MPLS, broadband internet, and LTE, just to optimize performance and cost. Last, just to summarize, and the key takeaways from this lesson, cloud service models include infrastructure as a service, platform as a service, and software as a service, each providing different levels of management responsibility. Cloud deployments model include public, private, hybrid, and community. And the cloud connectivity options include VPN, direct connections, and SD-WAN. Understanding these concepts is essential for both Network Plus exam and working with a modern network environment. Thank you for watching this lesson of Objective 1.3, and in the next video, we will cover Objective 1.4, where we explain common networking ports, protocols, services, and traffic types.